In today's video, I would like to share with you a very nice problem that was suggested by viewer. Here is the following equation for all integers x and y. We have this equation: x cubed plus 2 times x plus 1 equals y squared. Okay, in fact, this is very beautiful equation. It seems easy, but it's tricky. Okay, so it is a lot of tricks. So go ahead, pause this video if you would like to give that try to this problem. When you want to come back to see the full solution. Okay, let's get into the solution. Without loss of generality, we have x and y is a solution, and x minus y is a solution. We have to consider the negative solution as well, because we have y squared here. So here is the following equation: x cubed plus 2 times x plus number 1 equals y squared. Okay, so the way this equation is going to be solved, we are going to make a factorization in 3 different forms. Okay, for the first factorization, I'm going to bring this number 1 to the right hand side of this equation. Okay, so I will have x cubed plus 2 times x equals y squared minus number 1. Okay, for this one, I'm going to make x as a common factor for the left hand side of this equation. I will get x is multiplied by x squared plus 2 times equals y minus 1 factor y plus 1. Okay, here is the following roots. We have this one, this is a root, this one is a root, 0 is a root as well. Okay, so I'm going to put this one equals to 0 in order to solve this equation. Okay, so the right hand side of this equation equal to 0. That means the left hand side of this equation equals 0 as well. But this term is strictly superior than 0. That means x must be equal to 0, and y minus 1 factor y plus 1 equals to 0. Okay, so I will have the following solutions. I have x equals to 0, or y equals to 1, and y equals to minus 1. So we'll have the following solutions here. I will have x equals to 0 is a solution. I have y equals to minus 1 is a solution. So I will have another pair of the solution, which x equals to 0 and y equals to 1. Okay, so here is the first solutions. Now I'm going to look for other solutions. So I'm going to bring this same equation here. So this time I'm going to build the quantity square by adding minus x squared plus x squared. Okay, but I need x minus 1 quantity square. So by adding 4x minus 2x. Okay, so this 4x minus 2x is the same as 2x. Okay, plus number 1 equals y squared. Okay, now I'm going to take this x squared with this minus 2x with this plus 1. I will make a quantity square. So if you take this x squared with this minus 2x plus 1 is giving us x minus 1 quantity square. So I need also to make x minus 1 as a common factor by adding plus 4 minus 4. Okay, so I'm going to put everything separately. I will have x squared minus 2x plus 1. This is the first one. This one and this one and this one. So is this one. Okay, so I'm going to put this x cubed. I'm going to put this x cubed with this minus x squared. I will have x cubed minus x squared. Okay, and finally I will have 4x plus 4 minus 4. I will have 4x minus 4 with this one, then plus number 4. Okay, equals y squared. Okay, I'm going to move over number 4 to the right hand side of this equation. So now I'm going to factor out this one. Now I'm going to take x squared as a common factor. For the first term, I will have x squared factor x minus 1 For the second term, this one is a form quadratic binomial. It becomes x minus 1 quinary square. Okay, so for this one, I'm going to take number 4 out of this one. It's giving me 4 multiplied by x minus 1. Okay, I'm going to factor this one out. It will have y minus 2 factor y plus 2. So now I will have x minus 1 as a common factor for all terms. Now we have an expression of x minus 1. This x minus 1 is multiplied by x squared for the first term, and then is multiplied by x minus 1 for the second term. In the third term is multiplied by number 4. Okay, so it's giving us y minus 2 factor y plus 2. By simplifying this more, so we'll have minus 1 plus 4, which is number 3. Okay, this one become plus 3 here. Now here is the final expression for this one. In order to have a solution for this equation, I will put this one equals to 0. Okay, if you take a look carefully, this term is positive, strictly superior than 0, because x squared plus x plus 3 equals x plus half quinary square plus 11 over 4. Okay, that means this term is positive. Since this one is positive, that means this one must be equal to 0, not this one. Okay, so that means x minus 1 equals to 0, and y minus 2 factor y plus 2 equals to 0. This one x equals to 1, and they will have y equals to 2 and y equals to minus 2. Okay, so we'll have a pair of solution. We'll have x equals to 1 and y equals to minus 2. The second pair of solution, x equals to 1 and y equals number 2. Okay, I'm going to take these two solutions up here and clean up this board and look for other solutions. Okay, I'm going to solve again this equation in different way. Okay, so now I will have x, if you take a look carefully, x cubed here plus 2 times x plus 1. So what I'm going to do now, I'm going to add 529 minus 512 minus number 17. Okay, this one is giving us 17. Okay, minus this 17 equals to 0, as I'm doing nothing. Okay, so now this one equals y square. So if you take a look carefully, this term 529 is the same as 23 quinary square. Okay, 512 is the same as 8 cubed. Okay, now I'm going to take this 8 cubed, put it next to x cubed, and taking 512 and taking 23 quinary square and put it next to y square. Okay, to make the factorization form, I will have x cubed minus 8 cubed plus 2x minus 17 plus this number 1 plus 23 quinary square equals y square. Okay, this minus 17 plus number 1 is giving us minus 16. Okay, so I'm going to bring this 23 quinary square on the hand side of this equation and make number 2 is a common factor with this minus 16. I'm going to group this term with y square by moving over 23 quinary square to the right hand side of this equation, and group this 2x with this minus 16 and group this x cubed with this minus 8 cubed. Okay, so I'm going to factor out this one. This one is giving me x minus 8 factor x square plus 8x plus 64, okay? Because 64 is multiplied by 8 is giving us 512, okay? And they will have 2x minus 16 equals y squared minus 23 quantity square, okay? So here I'm going to take number 2 as a common factor here. I will have number 2 here. This one becomes 8. So if you take a look carefully, I have x minus 8 as a common factor for the left hand side of this equation. So we'll have x minus 8 factor x squared plus 8x plus 64. This one is multiplied by this one. This x minus 8 is multiplied by number 2, okay? So for the right hand side of this equation, this one is giving us y minus 23 factor y plus 23. I'm going to make some simplification here. 64 plus 2 is 66. It's giving us 66. If you factor out this term, is giving us x plus 4 quantity squared. If you distribute, this one is giving us x squared plus 8x plus 16 plus 50. This one is strictly superior than 0. So if I wanna solve this equation, I put here equals to 0. Okay. So since this one is different than 0, because this one is strictly superior than 0, that's mean x minus 8 equals to 0. Okay. That's mean x minus 8 equals to 0. Okay. If you take a look carefully at these solutions and this expression which we have on the right hand side of this equation, for all x and y is strictly inferior than 2, we found one pair of solution is an odd number, okay? When we have the y is an even number, we found this solution, y equals minus 2, y equals number 2, okay? When you have y is strictly superior than 2, we found odd solutions, okay? Because y becomes 23 or minus 23, okay? So to have the odd solutions for the y, we have this expression. To have even solutions, we have the expression that we did before, okay? So now I will have, this one is giving us y equals 23 and y equals to minus 23. So we'll have a pair of solutions. For here, I will have x equals to 8. Now we have a new pair of solutions. We'll have x equals to 8 and y equals to minus 23 as a pair of solution. The second pair of solution, I will have x equals to 8, y equals to 23, okay? I'm going to group this pair of the solution and put it with this one. Previously, we found these solutions that we have, okay? But the problem, how do we know there is more solutions after this one, okay? Like this is incomplete the answer, because you may have more solutions coming up. So if we think so far there is no solutions coming up, so we should show there is no more solutions. So the last solution was x equal to 8. Now let's set if x as a solution is strictly superior than 8. This one implies x equals to 8 plus another natural number plus p, where is p is a some natural numbers, okay? Not include 0, because you may have p equal to 1 and so on and so forth, okay? We don't know yet. So now I'm going to plug this one into this equation. So I have, by plugging this one into this one, so I will have p plus 8 cubed. If I'm able to show this one is not perfect square, I have done, okay? But this one, it seems more complicated to show this one. But there is a nice thing here. If you take a look at this number, 2 is multiplied by p plus 8 plus 1. So we're missing just p plus 8 quantity square to get form quadratic binomial, okay? So we will have p plus 8 plus 1 quantity square. So we are going to use the trick here. So I will have p plus 8 cubed minus p plus 8 square plus p plus 8 square plus 2 times is multiplied by p plus 8 plus number 1 equals y square. Now I have completed square here. Now I have this term. This one will be written on the form of p plus 8 plus 1 quinary square. Okay, now we have a perfect square here, but plus this term. If I don't have this term, that's mean I have a perfect square here. That's mean I have more solutions coming up. Okay, so it's clearly not easy to show this is not perfect square because it's involving cubed and square here and another square here. So to go through this way may not work. So I'm going to change another way. I'm going to solve this equation simply as I did before in the last factorization. Okay, I'm going to take 8 plus p quinary square as a common factor for these two terms. So we'll have, so by simplifying this term, this one is giving us p plus 9 as a first term quinary square, plus going to make 8 plus p quinary square as a common factor. I will have 8 plus p quinary square factor 8 plus p. This one is multiplied by 8 plus p. The second term is multiplied by minus 1. Okay, equals y square. Now by simplifying this one more, I will have p plus 9 as the first term quinary square plus 8 plus p quinary square factor. This one is giving us p plus 7, 8 minus 1, okay, equals y square. So now I'm going to move over this term to the right hand side of this equation. Okay, so I will have 8 plus p quinary square factor p plus 7 equals y square minus p plus 9 quinary square. I'm going simply to factor this one out. Is giving me y minus p plus 9 factor y plus p plus 9. I will have 8 plus p quinary square is multiplied by p plus 7 equals, I will have a nice expression here. Now I found a nice factorization for this expression. For the right hand side of this equation I have a product, and the left hand side of this equation I have a product as well. So that means if I'm going to solve this equation, I will have roots. I will have this one as a root and this one as a root as well. So since this one are the roots, on the left hand side of this equation is a root as well. So we'll have 4 roots. I will have this one, and this one, and this one. So now I'm going to solve this equation easily. So I will have, this one is giving us the following solutions. I will have, if I'm putting this one as an equation, so we'll have this one equals to 0. I will have plus p plus 9 equals to 0. This one is giving us the following solutions. Y equals p plus 9. The second solution is giving us is minus p minus 9. Okay, for these two solutions are okay because y, it could be positive, it could be negative, but for the two solutions must be positive because we have chosen p as a natural number, which is p is strictly superior than 0. Okay, but we found these solutions are negative, which is impossible. Okay, this one is giving us a stronger contradiction, so that means we have no solutions, no solution for x strictly superior than 8. Okay, so when we have x is inferior or equal to 8, we found these solutions, but when we have x is strictly superior than 8, we found no solutions by this contradiction. Okay, I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.